In this session, we are going to learn the inverse Laplace transformation. And then first, let's try to understand why do we need inverse Laplace transformation, right? We have learned the Laplace transformation, but look at that now. We say we're going to need to have an inverse Laplace transformation. But I want to make a summary before I start the inverse Laplace transformation. Let's see what we have learned so far. What we have learned, the first thing we have learned was the Laplace definition, right? So Laplace, we define the Laplace transformation in this way. An improper integral, we said, right? This is my Laplace definition. You need to take this integral if you want to find out a Laplace transformation of any given function. But later we noticed that this integral is so hard to take it. And then we use this definition to find out, right, some Laplace of elementary functions. And then we created a table. So in that table, right, you can find the Laplace of something like these. All these functions, if you remember, we use this definition to find out the Laplace definitions. So on and so forth. I'm not going to make a list of all those functions we found, but you remember, right, what we did for these functions. So we said that we have the linearity of the Laplace transformation, right? Linearity of Laplace transformation. And then we use the linearity, right, to find out the Laplace of the sum of the functions. So Laplace, linearity of Laplace linearity of Laplace says you can separate the functions and then take the Laplace separately. And also you can take the constant out and then take the Laplace and then multiply the constant later, guys. So we learned a lot of other things besides these rules. If you remember, right, when you are given the Laplace of any given function, let's say you have a function and then you know what the Laplace is. If you want to find out, right, the Laplace of this, the Laplace of this function is going to be just the shifting version of, right, your Laplace of f. And at the last class, in the last class, right, and then we asked this question, what is the Laplace of y prime? And then we saw that this is equal s times Laplace of y minus y0, and then the Laplace of y second prime, which is equal s squared y of s minus s y0, and then minus y prime 0. There are some other Laplace operation for the higher derivative, but I'm not going to list them. You can find out them in the table, guys. Okay, in this lesson, we're going to learn the inverse Laplace transformation, but first, right, we need to understand why do we need an inverse Laplace transformation. So after learning the y prime Laplace and the y second prime Laplace, we noticed that we can take the Laplace of, right, any given derivative. Since we said we are going to use the Laplace transformation to be able to solve the differential equation. After learning the Laplace of the derivative, we feel we are ready to solve the differential equation using Laplace transformation. If you feel ready, why don't you try it? So let me try it. Right? This is going to be the first time using the Laplace to be able to solve the differential equation. Let me try it, and then let me see, right, if I can solve a differential equation using the Laplace transformation, since that was the claim at the beginning, right? We did. And then let me see if I can realize that claim. So how am I going to use the Laplace to solve the differential equation? In this way, guys. So I need to take the Laplace of the given differential equation in this way. So I'm gonna take the Laplace of both sides. Look at that. All equality, right, needs to be replaced into my Laplace. So from here, you need to take the Laplace of the left-hand side and the right-hand side separately. So Laplace of y second prime minus y, and then Laplace of negative t. And then look at how I am going to use all the rules I have learned. For the left-hand side, I can use the linearity feature of Laplace transformation. That is why the left-hand side, right, can be expressed in this way. And still I have the right Laplace of the negative t. So can you please help me now? What is the Laplace of y second prime? From the table, you can read the Laplace of y second prime is equal s squared y of s minus s y0 and then minus y prime 0. And now what is the Laplace of y, which is equal y of s? By the way, instead of write the Laplace of y, from now on I'm gonna use this notation. So Laplace of y is equal big Y of s. Now what is the Laplace of the right hand side? Negative 1 over s squared from the table. Okay, now my job is to find out what the Y of s is, right? Since that's the only unknown here. If I use my initial value, since y0 is equal 0, that's going to be 0. Y prime 0 is equal 1, that's going to be 1. Y of s's are common terms, so I can use to group these terms. I'm going to have negative 1. Negative 1 over s squared. So on the left-hand side, still I have y of s squared minus 1. Now let me move the negative 1 to the other side. Okay. If you simplify this expression, you would get this one. S squared minus 1 over s squared minus 1 times s squared. So s squared minus 1 can be cancelled. At the end of the day, you are going to have 1 over s squared. Okay, so great. Y of s is equal 1 over s squared now. I ended up finding the y of s. But my claim and then my purpose was to find out the solution to this differential equation. Is that correct? What is the solution to this differential equation? If you remember, right, from all the discussion we have done, right, so far, the solution is, as you know, y of t. But look at that. I need y of t, but what I have, y of s. Can you please pause the video and then ask yourself, what is the relation between the y of s and the y of t? As you know, right, the Laplace of y of t would give you the y of s. But look at that. You have the y of s, but you need y of t. What other operation you need for this, right? Since you need to find out the y of t, not the y of s. There is only one operation in math, right? You can use for this purpose. You need to take the inverse of the y of s to be able to find the y of t. That is why, guys, we are going to need an inverse Laplace operation to be able to find the solution. That's going to be the standard procedure when we solve, okay, differential equation using the Laplace. At the end of the Laplace transformation, you are going to always find out an y of s, and then you need to take the inverse at the last step so that you can find the y of t.